Introduction to Aerodynamic Objects, Tutorial 7, Propeller Propulsion. And in this tutorial we're going to add a propeller to your aircraft and demonstrate powered flight. So what we're going to do is create a propeller from two wing-like objects attached to a hub. Then we're going to spin this propeller to generate thrust, add a simple undercarriage to the aircraft, and then finally make a powered takeoff. Scene diagram is pretty much like tutorial 6, except we now have a propeller as well as a tail and a wing, and this propeller is made up of two aerodynamic objects. We've got a prop blade 1, prop blade 2, and they're essentially copies of the wing, but they're spinning around on a propeller hub. So here we are in Unity, and we're kicking off pretty much exactly where we left off in tutorial 6. We've got our glider, but today's job is to put an engine on it so it can fly under its own power. And first job we're going to do is just a renaming one, but since it's now going to have an engine on it, let's just call it aircraft. Expand that out. And because we're smart and lazy, or maybe just lazy, we are going to create a propeller by reusing the wings. So what we can do is duplicate the wings, drag them forwards. So this may look a bit crazy, but you soon get the idea. If we have them there, and if we can rotate them around the Z-axis and twist them a bit, we can make ourselves a propeller. And that saves us rebuilding a lot of the stuff we've already got on the wings. So we're going to rename this second wing as propeller. And if we open this up, we've got starboard and port wings, which don't really make any sense anymore because this is spinning round. So what we're going to do is rename this blade number 1 and blade number 2. So first job is now to alter the geometry. So if we select both of those geometry transforms, and let's kick off the offset we had in there. So it's at 0, 0, 0 in the Z sense, and let's get rid of the dihedral. So that was our angle about Z, so they're now flat, and we want to make them a bit smaller. So they're going to be 1.2 meters that way. They're going to be 1 centimeter thick, and they're going to be 25 centimeters chord. Okay, and let's drag them back a little bit, put them on the front. So looking a little bit more like a propeller. But still, if we swizzled it around the Z-axis, all it would do is just be producing drag. So what we need to do is put some twist on it. So we're going to do that in geometry, but we need to do it differently for each one. So if we take blade number 1 and then twist it about the X-axis by 60 degrees, and then go to blade number 2 and twist it by -60, we get some twist on there. And there's only two things you really need to know about a propeller. That's its diameter and its pitch. So diameter, obviously, distance between the tips. The pitch is, if you imagine this is being screwed into cheese or something, it's how far that propeller would go round in one rotation. And it's related to the angle of the blades here. And if you want to go really fast, you need an aggressive pitch angle. But if you want to produce lots of thrust, when you're not going fast, say when you're taking off, you want a more shallow pitch angle. So when you're tuning an aircraft propeller, you have to choose the pitch angle of the blades quite carefully, depending on the speed of rotation of the motor and how fast the plane is going. Okay, so that's looking like a propeller. And just for visuals, it doesn't seem quite right just sticking that straight on the air. So just to keep the eyes happy, what we're going to do is put a little hub on there. So if we do this at the level of the propeller, I'm going to do right click, 3D objects, capsule, and I'm going to rescale it down to 1/5 the size, and I'm going to rotate it 90 about X, and that gives us a sort of thing, looks a little bit like a hub or a motor, but kind of tidies up a propeller a little bit. Okay, I like that, that's good. Okay, let's do some work on the aerodynamic side of it. So if we go to the aerodynamics of each of these blades, get them both out. So I'm going to multi-select them using Control. We're still attached to the rigid body, which is good, so the aerodynamic forces from this is going to be communicated or sent to the rigid body of the overall aircraft. But one thing we really will need to change now is change the velocity source to transform. And the reason that's important is that if you imagine the rigid body is sitting stationary here, if the propeller is spinning round, those propeller blades will be generating lots of force because they're moving really quickly, but obviously the rigid body is not moving, so it's the movement of the transform that is generating the aerodynamic forces, not necessarily the movement of the rigid body. So I set that to transform. And what else we need to do? We've got lift and drag arrows on. I'll tell you what, let's just get rid of the drag arrows. We don't really need to see those, so I'm going to remove those. And then for our lift arrow, I'm going to make it just a little bit smaller so it's not too much in the way. So I'm going to set it to 0.05, and I'm going to reduce the sensitivity a little bit to 0.05 as well. What we're going to do next is move the location of the aerodynamic object on each of those blades. And the reason we're going to do that is that when you're spinning something around like this, obviously the velocity increases further you go out. And really this is just to show something about the way the aerodynamic modelling works. But the centre of this panel here is where this is going to get its velocity from. So actually from a physics modelling perspective, it's better to have it further out. And typically on a propeller, you use 3/4 span point as your control point when you're working out the aerodynamics. So what we're going to do is shift our aerodynamic object out by 0.25 in that direction to get it at the 3/4 span position. So if we do this one first, and if we put an offset in there of 0.25, that shifted it out. And on the other one, I'm going to do an offset of minus 0.25. And the other thing this illustrates is the difference between the error object itself and the graphics. So the graphics are there for us to look at. The error object here is what the underlying model is using for its calculations. So the thing the model needs to know is where the center of this panel is and the orientation it's at. So this blue box really here is telling us this is the orientation, this is the center, and the size of that blue box is representative of the reference area of that surface. So we're not doing panel methods in CFD, but we're using that geometry to make a reasonable approximation of what that blade has done. And if you compare this model to actual data you get from doing thrust experiments on propellers, it's actually pretty good. So even just using one control point like this on a blade, you can get answers that are within 10-15% of what you get if you did a real experiment. Okay, we are going to need to change up our script, so let's get rid of the previous aircraft manager and add aircraft manager for the tutorial 7. And this one has got the center of mass marker on it as before, but it's also got a prop hub and a speed slider there. So this is what we're going to use to control the speed of our propeller. So what we need to drop in is the top level transform for our propeller. So I'm going to drag that in and put that there. So there's a couple of other things we need to sort out before we do a thrust test, and they are our street line objects have been left on since the wings and they're miles away, and actually we want to put them on our propeller. So let's get on and do that. So I'm going to go into ortho mode, drag it in, know exactly where they are, somewhere close is good enough. And okay, that'll do. So got our street lines on. What else? In terms of the environment, I think we've still left our flow on. So yeah, our uniform flow is still on at 1, so I'm going to turn that off. So we've just got some stationary conditions. And I think we're ready for a thrust test. So we need to make sure that it's held in place. So aircraft need to make sure is kinematic is ticked, so it's going to stay fixed. We've got a little bit of prop speed on, so it should start spinning straight away. Let's give it a try. Okay, it's looking promising. So we've got a little bit of lift on each of the propeller blades. It's going around quite slowly. Let's try and increase the speed. And there we go, we've got a propeller. And if you do Control Shift P, that pauses it. So we can have a look at what's going on. So we've got a nice amount of lift on that blade. The other blade's pointing the other way, that's got some lift on it. And if you do Control Alt P, you can step through the simulation. And that's how a propeller works. So basically 2 wings set at an angle, going round, they're generating lift, and that's going to be pulling our plane along. And if you do Control Shift P again, it'll go up to full speed. If your project settings, if you don't have a fixed time step of around 0.002, you'll find this gets pretty chunky when you're running fast propeller speeds. So when things are rotating fast, you do need to be able to use a small time step, else the propeller goes around an awful long way in each step. Great, let's stop that. So we were nearly ready to give it a launch, but one of the obvious things we seem to be missing is some undercarriage. So that propeller is going to hit the ground. So let's stick some undercarriage on. Unfortunately, I made some earlier. So if you go to prefabs and find undercarriage and just drop that on the top level of the aircraft, the undercarriage will magically appear. And the positioning of it, general rule of thumb for tail draggers, so if you just got one gear like this, it's called a tail dragger because it sits on the ground when you let it go, is that the undercarriage should be just ahead of the centre of gravity. So it kind of tips back on the ground, but not so far that it can't pull itself off once the thrust is on. Okay, grab the top level transform and let's just take it away from Aeroman because we don't want it on his head, and lower it down to the ground. So leave it just slightly above the ground so it settles nicely. And our tailplane setting angle is the same as what we had last time that we left it at. So let's just check what that is. So we were under fuselage and tail, horizontal stabilizer, geometry, and it was set to -8 degrees. So that's okay. So that's quite a lot of. It's going to be trying to fly really slowly, but that's fine. I think we're ready to give this a go. So I'm going to uncheck is kinematic. I'm going to start off at 0 prop rotation rate. Okay, let's see if this goes. It's promising. So we dropped the aircraft. It's settled on the ground. Just going to turn gizmos off just briefly. I think we're ready for a flight. So we've got our cameras set up, but let's just try this just using scene view to start off with. And so what I'm going to do is increase the propeller rotation. Propeller starts spinning, and there we go. We're going forwards, a bit more thrust, and there we have it. We've just done a takeoff. Okay, we got it back on the ground too. So that was interesting. So when it took off, it pulled to one side, and that's not because we've got the fin is actually on straight, and the reason is you get a torque from the propeller, and so the drag on the blades, a bit like the drag on the wing, is actually trying to slow the propeller down, but that is acting as a torque effectively on our propeller hub, and that's causing the aircraft to twist in the other direction, and that's what causes it to turn. Okay, let's get our camera set up so we can get a better view of it. So we can do play focused, and these cameras have been set up same as last time if you've done the previous tutorial. So we've got our cameras, and the default camera is orbital. I think we can give it a go. Got our orbital camera. Let's go in slightly. You can use the wheelie mouse button on the orbital camera. Go to our aircraft and chocks away. And there we have it. We've got a plane that's got its own propulsion system. And what's slightly weird is you haven't really got any controls at all apart from the thrust. But if I take the thrust off, it'll go straight because there's no torque left on the propeller. And there we have it. We have built a fully functioning propeller from 2 wings that we've twisted, and it's got exactly the same aerodynamic objects on it, but these aerodynamic objects are now being spun round, so they're producing thrust like a propeller. Great, so that brings us to the end of this tutorial, and in the next tutorial we're going to put some control surfaces on the aircraft so we can fly it. We're controlling both pitch and roll, and we can find out what this plane can really do. Okay, look forward to seeing you in the next tutorial.